Alright. First definition, this will be on your test that's going to be coming up, is matrix. A matrix is an array of values organized into rows and columns, which y'all have dealt with matrices in Algebra 2 with trig, so this is not really new. This is what a matrix looks like. Matrix row operations are very simple. This whole first page, all you're going to do is carry out the operation they're asking you right here, which is swapping row 1 and row 2. The only thing you have to remember, make this a matrix, I'm sorry, I don't know why my computer didn't print that out. Are rows vertical or horizontal? Good. Write that up here. Horizontal. So for this matrix, this is what we're dealing with for all three of these. Row 1 has what numbers in them? Just say them out loud. This matrix, what numbers are in row 1? Yes. Good. So everybody knows what I'm talking about. This is row 1, row 2, row 3. So matrix row operations, all it's doing right here is saying swap row 1 and row 2. So you're going to rewrite this matrix except swapping row 1 and row 2. So right here I'd put a what? 1, then what? 2, negative 3, very good, and then 5. So I put row 2 in row 1 spot, and then I swap this one as well. And then the last row just stays the same. Very easy. We won't spend a lot of time on this. Row 1, when it says 1/3 row 1, that just means multiply everything in row 1 by 1/3. So instead of 3, what's 3 times 1/3? Good. 3 over, not 3 over 1, but 3 over 3, which is 1. Next one. Next. Next. Good. And everything else just stays the same. Questions about that? How to get the first row? You're dividing all of everything in row 1 by 3. So 3 divided by 3 is 1. 18 divided by 3, oops. Yeah, is 6. This divided by 3 is negative 4. This divided by 3 is 7. Yes. The only thing we're dealing with is row 1 right here. Alright, this next one didn't print out what I wanted it to either. You're going to do this one on your own. You're going to take everything in row 2, multiply it by 2, then add 3. And I want you to replace row 3 with this operation. So leave 1 and 2 the same. Replace row 3 with 2 row 2 plus row 3. Okay, we'll do this one together. Okay, leave row 1 and row 2 the same. Go ahead and write those. Now I'm going to change this row to 2 row 2 plus row 3. So first number in row 2 is what? 1. 1 times 2? Plus row 3, which is negative 2. It's going to be what? Good. Everybody see what I did? You take 1, which is row 2, multiply it by 2, add the first number in row 3 and get 0. Let's do the next one together. Next number in row 2 is what? 2. So 2 times 2 plus this number, negative 3. That's going to give me what? Good. Go ahead and do these last 2 spaces in row 3 on your own. Alright, Amber, what'd you get in this spot? Anybody get anything different? Good. Let's go over how we got that. We're going to take what number and multiply it by 2? Yes. Negative 3 times 2, which is what? Very good. You might have just made that a positive 6. Okay. And then, Antonio, what'd you get for this one? What'd you get? Anybody? Good. Any questions? All right. Do we need to do more problems like this, or y'all good?
I think we try.
We need to do another one? Okay, good. These are just called one more?
I'm sorry.
Okay.
I tried it out. I didn't have this wrong yet.
Yeah, you have to think.
Okay, that's
Yeah,
fine.
you got some real
I want
quick
you to do this one on your own. You're replacing row 3 with this. Go ahead and do it on your own. So this is the matrix you're dealing with, so leave rows 1 and 2 the same. You can go ahead and write them actually. 1 and 2 the same. Go ahead and change row 3 on your own.
Would you multiply it by 3 and then adding the third row?
Yeah, you're going to multiply first number in row 2 by 3, then add this and put it right here in the new spot.
I'm sorry.
You take the first number in row 2 and multiply it by 3. And then add the first number in row 2. So it'll be 3, what can you do with it?
3 plus negative 3? Negative 0.
So the next one you take 6 times 3 and take negative 2 and put it right here.
6 times 3.
So 6 times 3 would be
18. So why you going?
negative 2.
Why you getting 6?
Because that's what row 2 is.
Oh, so the same like the entire row?
Yes.
Okay, thank you. Thanks.
Did y'all do matrices and breakdown?
Yeah, we did.
Yes. Alright, Kayla, what'd you get for the first one? Good. Colby, what'd you get for the next one? Looks good. Cade, what'd you get for the next one?
You know what? I'd be honest. I don't really understand. You're multiplying negative 3 by 1. Oh, I was looking at the first one.
Oh,
I guess
gotcha.
we can look at the third one. 1 by negative 3, and then adding 1.
Mm-mm. You're taking 3 times this number in row
So
2.
negative 9.
And then plus,
Plus 1.
yes.
So negative 8.
Yes.
Okay.
Does that make sense?
Does now.
Okay.
I was not getting that. Because the way it was, the problem was set up.
Gotcha.
But
I think why is the 8, 7, and negative 9 like a bar in between them?
Oh, we'll see that in a minute.
Okay.
It's really systems of equations. These are X, Y, Z. These are the answers. We'll see in a second.
Like 3 and R2, they're kind of swapped when we
it's
solve
just
it.
like
Gotcha.
I think that's what throws us off.
Yes, Antonio.
I got 12.
Oh, thank you. All right. Any of them in here I need to go over? This is just I can perform matrix row operations. These are just called row operations. Everybody's good with them. All right, flip over. This is where it gets kind of tricky. We won't get to do many examples because these take a little bit of time because they're like a puzzle. Puzzles take time to figure out. So, but if you are done with your test, after I go over this one, I want you to try one of these on your own. The other thing that's kind of different with this is there's no correct step to take when you're solving these problems. Like Victor could go one direction with this problem, Colby could go another, do other steps, but still get to the same answer. Alright, here we go. Stay with me. First thing we're going to do is create a matrix out of these 3 systems of equations. In the first column, which is vertical, are going to be our coefficients of our x values. So what's my coefficient for this x value?
2,
Next.
1.
And good. The next column is going to be our coefficients for our y value, so that's going to be what?
1.
And
Two.
good. Z's.
2 and negative 1.
And then this is where we draw our line because this is pretty much our equal to sign. Think of it like that. All right, our coefficients on the other side of the equal signs. Good. Our goal is to make this side of this line look like the identity matrix. Now, you might not have seen that or heard of that in a while. Does anybody know what the identity matrix is? Yes. This is our goal, right goal above this. We want to make this matrix right here, this 3 by 3, be 1's in the diagonal, 0 everywhere else. This is called the identity matrix. Y'all remember that? No? We want to make this side look exactly like this. We don't care what this side looks like. Just that this matrix needs to look like this. So here's the suggested way that would be easier to do this. First, we need to make this be 1. Then these two be 0. Then move to this diagonal and make this be 1. And how are we going to do that? By row operations. By what we just did. Okay? So looking at this equation, this 2 right here, we want to make this 2 be a 1. That's our first step. So what I'm going to do is subtract row 1 minus row 2. Stay with me. Alright, here's how I want you to write your row operations. What row are we changing again?
1 and 2.
No, what row are we changing? Just row 1. We just want to change this to a 1. So that's what goes underneath. This lets me know that you're changing row 1.
What's that arrow for? Sorry.
Kind of like up here, it's just showing that we're about to do something to our matrix.
All right.
That's all. So row 1's what we're changing. I'm going to do row 2, or actually row 1 minus row 2. So the only thing I'm changing is row 1 again. So all of your row 2 and row 3, go ahead and rewrite that the exact same as it is. Again, because row 1, what's underneath is the only thing we're changing right here. Zoom in. I'm going to replace row 1 with the values I get when I subtract row 1 from row 2. So starting here, row 1 minus row 2. 2 minus 1. Good. Next would be 1 minus negative 1. 2 minus 2. 18 minus 9. Good. What was the point of this? We wanted to get what? 1 here. Now we want to get 0 in this second row, this first number. Right now it's a 1, we want it to be 0. So what row are we changing? Row 2, that goes on bottom. Good. And let's see. We could subtract row 2 from row 1. We could do row 2 minus row 3. See how there's a bunch of different options? That's why I'm saying it's like a puzzle. There's no right way or wrong way to do it. You just might be a little more complicated which way you choose. Go ahead, Victor.
Can I see the original matrices?
Yes.
We're subtracting, right?
I'm subtracting row 1 minus row 2.
So shouldn't that first 0 be 2? 1 minus negative 1?
1 minus negative 1. Yes, thank you. Good call. Everything else looks good. Yeah. Y'all see what he was saying? We're subtracting them, row 1 minus row 2, so it's 1 minus negative 1 right here. 1 minus negative 1, which would keep, change, make 2. Alright, so I will let y'all choose. Do you want to do like row 2 minus row 3, row 2 minus row 1? What do y'all want to do?
Row 2 minus row 3.
Alright. What's the 2 rows that are going to stay the same here?
1 and 3.
Yes, go ahead and write them. Alright, so we can look right here. We're doing row 2 minus row 3. So 1 minus 1. Good. Now we got negative 1 minus 2. Say it again. Yes, very good. Alright, now we got 2 minus negative 1. Good. Again, 2 minus negative 1. We'd have to keep, change. That would make 3. 9 minus 6. Yes. Looks good so far. So we have got, this one is 1, this one is 0. Now we need this one. Row 3, 0 right here. So again, what row are we changing? Row 3. And how could we make this be 0? Give me an easy scenario. Yes, row 3 minus row 1. Looks good. So we can leave row 2 and 1 the same. So I'm going to go ahead and rewrite those. Alright, and I'll just let y'all tell me what goes in what spot whenever you're ready. 0. 0. Next one. Negative 1. Good. Go ahead. Perfect. Everybody good so far? Right here. 6 minus 9. Row 3, which is 6 minus 9.
Could you show the goal that we're trying to get to?
Yes, we're trying to make this part look like this. All ones in the diagonal, 0 everywhere else. And we're close. We got zeros here. We just need another 1 right here. 1. How could we make it a positive 1? Multiply by negative 1. We can do that. So we're changing which row?
The third row?
Yep, and we're just multiplying it by what? Yes. Go ahead and do that. So everything else stays the same. We got 0, 0, 1, 3. Alright, go ahead.
Is there a specific reason that we're trying to get diagonal zeros?
Yeah, wait, diagonal ones you mean?
What, like the goal that we're trying to get to?
Yes, because in a matrices, once you've solved this, these were our x's, correct? So once we've got this, we can say x equals whatever number's over here. Say if it was like 1, 1, 1, you say x equals 1. This is our y, so y equals 1. We're solving for x, y, and z.
Okay.
And why are we going to make those 1? I don't understand that.
Why are these ones?
Why are we going to make them 1?
So that way it can just be x by itself. If it was a 2 right here, it'd be like 2x equals 1. We're getting x, y, and z by itself.
Okay.
Alright, the next thing we need to do, we got all this done, is make this middle term in row 2 a 1. Yes.
So when you're going from like the arrow to row, make your C's or whatever, are you using the new things that you found, or are you using the original one you started?
The new things we found. That's why we like when we go from here to here, we don't change anything except the row that we're dealing with. Alright, we're trying to make this be a 1. Tell me some different ways we could do that.
That's clever about negative 3.
Yes, we could divide everything in here by negative 3. Wouldn't that change that to a 1 in the middle? Let's do that. So we're changing row 2, dividing it by, what'd you say?
3, negative 3.
Yes, very good. So leaving row 1 the same, which was 1, 2, 0, and 9. When we divide everything in row 2 by negative 3, what would we have?
1. Negative 1.
And then,
Negative 1.
yes. Very good. Alright, so we just need to make this and this a 0 right here. Alright, let's focus on, it really doesn't matter which we do first, but I see this one an easy way we could make this be a 0. How's that? How could we make this be a 0 without changing anything up here?
Which one first?
I'm trying to make this right here be a 0. But I don't want to change the 0 and 1 because that's supposed to be there. What could I do?
Oh.
Yes, very good. You could add these two. Because this wouldn't change, this wouldn't change, this would change. Everybody see that? Okay. So we're changing which row? Good? By doing what? Yes. Alright, so row 1 stays the same. Row 3 stays the same. When I add row 2 and row 3, what will be my first term? Next. 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 Good. Almost there. We just got to make this be a 0. Just this one. Any thoughts? First of all, you can go ahead and do this. You know you're changing row 1. We don't want to change the 1 and the 0. Just this. Say that again. First and the third wouldn't change anything here, right? Because there's a 0 here. It'd be the first and the second.
2 or 2.
Very good. I'm trying to get this to be a 0. So it'd have to be something in this row, or excuse me, this column to change it.
R1 minus 2 or 2.
Very good. So we could do row 1 minus, and what'd y'all say to multiply this one by?
2.
Very good. Row 1 minus 2R2. Why would we want to do that? If we multiply this by negative 2, subtract it from here, give us 0. Everybody see that? See how it's like a puzzle? You just kind of have to think about what's going to cancel this out but not change anything. Alright, so everything else you can leave the same. Row 2 and row 3. Now, row 1 is going to be 1 minus 0 times negative 2. So this is going to leave us at what? 1. Good. Alright, now we got 2, row 1. This is 2 minus 2 times row 2. That's going to leave us what? Good. And we have zeros here, so 0 minus 2 times 0 would just be what?
0.
And then we have 9 minus 2 times 2. So it'll be 9 minus 4, which is 5. Good. Now, we have the identity matrix here, which is good. That means we've solved for x, y, and z. So x equals what? Y and z. Very good. So you can see these are lengthy, and depending on the path that you take to make it the identity matrix, you might be shorter, it might be longer. Let me go back to this first step we did. When I subtracted row 1 from row 2, I could have subtracted row 1 minus row 3 and still got 1. Thank you. It's 1037, but thank you. And to check these, you can just plug them back in for x, y, and z. It'll work for every single equation. Any questions?
Very responsible.
Alright, if you are done with your tests, what I'm going to do is have you try this next one. You should not get any fractions for your answers. If you're not finished with your test, go ahead and clear your desk off.